Okay, so today we're going to be looking at questions 23 and 24. But first, on the space that I left, that's question number 22, let me specify what type of triangles do we have? Okay, so we're going to classify triangles, and we have three different types of triangles. Triangles have three sides. We happen to have three types of triangles. I'm going to say the names. The names of the three triangles that we have. One of them is going to be scalene. So let me just write these things down. Scalene. The other one is going to be called isosceles. And the last one, the third one, we're going to call this equilateral. Those are the three types of triangles that we have. Now, what makes the difference between them? For scalene, what's a scalene triangle? All sides are different. All sides are different length. Okay, all sides are different length. What do you mean with that, Mr. Dunn? So can you give me an example? Sure. Let's say I have a triangle here, not drawn to scale, so don't come and measure it. But let's say one measurement is 5, the other measurement is 6, and the third measurement is 10. Right? It has three sides, but all three sides are different length. That's what a scalene triangle is. Now, what's an isosceles triangle? Kind of sounds like I something. Well, interesting is that the sides of a triangle are called legs. Uh, when it's a right triangle, the biggest one's called hypotenuse, but the other two are called legs. Interesting. I have two legs, right? Most people have two legs, and let's just say they're about the same length. So they're the same length. So we're going to say isosceles triangle. We're going to say two sides are, are equal, are same length. Or better yet, two sides have same length. Okay. Isosceles where are triangles where two have the same length. Can you give me an example, Mr. Johnson? Sure. Let's just say I have a triangle here. One side is 5, the other side is 5, and the third one is 8. That would be an isosceles triangle. Two sides have the same length. Now, equilateral, kind of like the name says, it's equal, sounds like equal, lateral means sides. Equilateral will equal sides, right? So in this case, an equilateral triangle is all three sides have same length. I know for constructions I've done this. I've showed you guys an equilateral triangle, and I call it equilateral, and I drew it with a compass. Now all the sides have the same length. But give me an example, Mr. Leonson. Sure. Let's say I have a triangle. One side is 7, the other side is 7, and the third side is 7. So scalene, all the sides are different. Isosceles, two sides are equal. Equilateral, all three sides are equal. I could easily give you guys a triangles with the measurements and make that, what, a sixth grade level? But we're not in sixth grade. We're in high school. So we're actually going to prove stuff. So now here, given the shape with the vertices, and it gives me three corners. The corner X, the coordinates are 2, -4. The coordinates of Y are 4, -12. The coordinates of Z are 11 and -6. Now here it says show. It doesn't say tell. Show the triangle scalene, isosceles, or equilateral triangle. Okay. So I have the three corners. So what do I need to do? Find the length, the length of each of my triangles. That's how I'm basically going to show. Find the length. So it gives me an idea. Maybe that's why we just review. We just reviewed the distance formula. Remember slope formula, distance formula. That is the reason why I said we need to review this. Okay, so now here, XY. as a reminder, what's the distance formula? Let me write it up here. Let me write it in blue so we can see it. The second y minus the first y all squared plus inside parentheses the second x minus the first x all squared inside a square root. Okay. So here for the distance xy basically says use the point x and the point y. We're not using z at this point for the side xy. So x is going to be my first point and y is going to be my second point. So here, my first parentheses, subtract the y's, right? So negative 12, the second y minus the first y. So negative 12 minus a negative 4, which is squared, plus second parentheses, I'm subtracting the x's, right? 4 minus 2, all squared. Some of you might be like, does it really matter the order? Like, do I have to write in my first parentheses negative 12 minus a negative 4? What if I go the other way? Negative 4 minus a negative 12. What if I flip it? Or the second parentheses, instead of 4 minus 2, what if I write 2 minus 4? Doesn't matter. Well, the difference, if we switch the number, the difference will be the sign. Let's say I get a negative answer, you get a positive. Let's say I get a positive, you get a negative. The sign is going to be the difference. That's really going to be it, the only difference. The funny thing is, because we're going to square the parentheses, when we multiply a number by itself, doesn't it become positive? Hmm. In that case, my order will not really, really matter. So looking at here, in my first parentheses, two negative signs become a plus sign. What's negative 12 and a positive 4? That's a negative 8. Now remember how I just said, and this is the reason why I said it will become positive. Negative 12 plus a 4 is, I know it's a negative 8 because I'm going to square it. In reality, I'm just really looking at the number 8. I'm not really looking at the sign. Plus, my second parentheses is 4 minus 2 is 2. So I'm going to call that 2 squared. So 8 squared plus 2 squared. I'm going to type it in my calculator. Good thing I gave you guys a calculator already. So remember, go to Canvas, open in a new tab, and then I'm going to open my calculator here. So I have square root of 8 squared plus 2 squared. Entered. Okay. Let me just round it to two decimal places. Okay. So let me call this what? 8.25. Unless I tell you round it to one decimal place. So matter of fact, yeah, because of the space, let's just do one decimal place instead. I don't have much space on our work here. So let me just go one decimal place. So I'm gonna call this 8.2. Okay. So the segment XY is 8.2. Okay, now let's figure what's the segment YZ. So I'm going to erase this up here. So I'm just looking for the segment YZ. I'm looking at the point Y and the point Z. Okay. So for my first parentheses, I had to subtract the Y's. So negative 6 minus a negative 12 squared. For the second parentheses, I have to subtract my X's. 11 minus 4. And then I said, which X do you write first? It really doesn't matter because the only difference is going to be the sign. But because I'm going to square it, write everything squared, it becomes positive. So, okay, my first parentheses, two negative signs become a plus sign. Negative 6 plus 12, isn't that 6? So I'm going to say 6 squared. On the second one, 11 minus 4, that's 7. So this is about Let me go to my calculator. 6 squared plus 7 squared. The square root of 6 squared plus 7 squared. I'm going to round it to one decimal place, so let me call this 9.2. Okay. I'm showing my calculator for this question. I'm not going to show my calculator for question number 24. But I'm going to say YC became 9.2. Okay. So far, my two sides are not the same. So it's not an equilateral triangle. Because remember, equilateral, all three sides will be the same. Now for the third one, let's go with green. The segment ZX. So I'm only using the coordinates of my point X and my point Z. Okay, so let's start by first parentheses, subtract the Y's. So I'm gonna go -6 minus a -4 squared. Then subtract the Y's. 11 minus, subtract the X's. 11 minus 2 squared, and all this inside a square root. Interesting is here, two negative signs become a plus sign. And here's a trick I mentioned earlier. Don't know if you guys quite got it on the segment XY, but I'm gonna use it again. Looking at my first parentheses, -6 plus 4. So -6 and a +4. Isn't that -2? However, I'm not going to write -2. I'm just going to write 2 and square. The reason why I ignore the negative, because I'm going to square it. When you square a number, it becomes positive. So I'm just going to ignore the negative sign. Plus 11 minus 2. I know that's 9. 9 squared. So I have the square root of 2 squared plus 9 squared. Let me grab my calculator here. Let me show you guys my calculator here. So square root of, what were my numbers? 2 squared plus 9 squared. Okay. So 2, oops, not outside, it's inside. So 2 squared plus 9 squared. Press enter. Make sure it is what you wanted to type. Yep. So this one says 9.2. Because remember, I'm running to one decimal place. 9.2. Cool. I see two sides are equal. Not all three. Two sides are equal. So now here at the bottom, scalene, isosceles, or equilateral. Two sides are equal. So in this case, I'm going to write isosceles. That's it. Right? I could have given you the three sides, 8.2, 9.2, 9.2, and then you said it's isosceles, but that's a sixth grade level. Here we're proving, we're showing. So we have to figure the three sides, and then we choose which triangle it is. Cool. Let's take a look at number 24. Now I'm not going to show you guys my calculator. I'm just going to say this is what I got on my calculator. So for the segment QR, I'm using the coordinates of Q and then R. And I'm going to start by subtracting the Y's. 9 minus 1 all squared. Plus subtracting the X's. 3 minus a -3 all squared. And this is inside the square root. The first parentheses, 9 minus 1, well, that's 8. So 8 squared. Plus, here in my second parentheses, two negative signs make a plus sign. So 3 plus 3, that's 6. So 6 squared. And I go to my calculator. I'm not going to show you, but you guys have access to a calculator through Canvas. So square root of 8 squared plus 6 squared. Happen to type it in and it says 10. Okay. Don't have to round. That's good. Now for the segment RS, I'm going to use the coordinates of R. By the way, this is R right here, and then S. Right? I see the R right there at the end. So I'm using the coordinates of R and S. This is why it says show. We're showing. Okay. So for my first parentheses, subtract the y's. 11 minus 9 squared. For the second parentheses, subtract the x's. I'm going to go 3 minus a negative 8. Might be like, wait a minute, why did you switch the order? I really going to start with the bigger number because I want to avoid negatives. Remember how I said earlier, the negative signs are going to become positives. So why don't I avoid the negatives from the beginning? Okay. So here, 11 minus 9, the first parentheses, well, that's 2 squared. Here in the center, two negative signs make a plus sign. 3 plus 8 is 11. So I have the square root of 2 squared plus 11 squared. I type it on my calculator. I'd round it to one decimal place, and it's going to tell me 11.2. Okay. Lastly, let me take a look at my side SQ. So for this one, I'm going to use the coordinates of S and the coordinates of Q. Let me start by subtracting the y's. 11 minus 1. And then let me subtract the x's. Remember my trick. I want to avoid negatives, so I'm going to start from the bigger one. Negative 3 is bigger than negative 8. So I'm going to write negative 3 minus a negative 8. Again, that is fine because if I don't switch the order, the only difference is going to be my sign, right? Positive or negative. But because I'm going to square it, becomes positive either way. So it is fine to flip the order. So in my first parentheses, 11 minus 1, that's 10. The second parentheses, well, there's a plus sign here. Negative 3 plus 8. So that gives me 5. And I'm going to type it in. The square root of 10 squared plus 5 squared. My calculator tells me 11.2. Guess what? This one's also isosceles. Pretty cool, huh? You guys figure it out. You guys have to show me. You guys find the measurement of the sides, and then having the sides, you guys will tell me whether it's scalene, all the sides are different, isosceles, two sides are equal, or equilateral, all three sides are equal.